All right, this is a question about acceleration. Okay, so did anyone get it right? Get correct for this question?
No.
Nobody. So this is why we are taking a look at it. Okay, underline the word straight line portion from the 50th to the 75th. Okay, so I'm going to give you guys a few options. The question asks for maximum acceleration. Now, in terms of a speed time graph, how can you find it out from the graph?
We take it is the gradient.
Find gradient. Final velocity minus initial velocity is a formula, but when it comes to graph, this is a graph, a speed time graph. Therefore, it's about finding gradients. This is graph. Graph has gradient, has area under graph. So in this case, acceleration is about finding gradient. So if they ask for the maximum gradient, it would be the maximum acceleration, it would therefore be finding maximum gradient. So I give you a few points lah. Point A, point B, point C, and point D. Which of these points represents which of these points has the maximum gradient? B. How do you know it's B?
It's a straight line.
It's a straight line is one thing, but when it comes to gradient, it's not about whether is it a straight line or not. This is also a straight line. This is also a straight line. Why is B then the one?
Because it's a uniform deceleration.
Okay, the reason.
It's only point in between 50 and 75.
Well, you can try to deduce from there. I mean, they give you this as a clue, so it's important to bring it out. But if we really want to know absolutely whether which point has the greatest gradient, you can actually draw a figure here. So imagine you're the one at the bottom of the hill. So this is a hill. So imagine that you're climbing the hill. Which point in which you feel like you're putting in more effort to climb? That would be B. Okay, this tells you it would be the steepest point. Right? Okay. With that, you can then find the gradient. What is the formula for gradient in terms of graph?
No, y over x. Y over x.
Rise over run.
Gradient is rise over run.
Yeah, the y over the x.
It's not just a y over the x, it's a change in y over change. So it's y2 minus y1 over x2 minus x1. In this case,
y minus 2 or y bracket 2? Wait, y2 as in 2 bracket y?
No, y2 is in y subscript 2.
Subscript as a square, essentially.
No, a square is a superscript.
Then how do I key in a subscript into my calculator?
You don't. So this is a formula for gradients.
Oh.
Look at the screen 7. So I'm about to explain to you how to calculate from the graph. It's a good thing that you are dealing with a line because a line is very simple. Let's see. Okay. So what you need to do is pick 2 points along the line from 50th second to 75th second. So 50th is here, 75th is here. You can take these 2 points, or you can take other points you want. So over here you have 1, 2, 3, 4, 5. So it's a 10. So over here you have 8 meters per second, and you have 50 over here. 25th will give you 28. So this is your y2. This is your y1. In terms of gradient, purely in terms of gradient. Okay? You can draw your triangle. All right? And then this is your x2, and this is your x1. Okay, so what do I mean by y2 minus y1? This is y2 minus y1. So this is your rise. So there's a little bit of math involved. And this is your x2 minus x1. And this is your run. So in terms of, when it comes to gradient, it's a ratio. The whole principle behind gradient is that it's a ratio. In very simple layman terms, is how steep something is, how steep the slope is. So in order to calculate the steepness of the slope, you have to find the ratio between the height of the slope and the running part of the slope, the horizontal portion.
Okay.
Later on, you will, if you are taking AMATs or other advanced mathematics, you will be relating that the gradient actually just additional information. The gradient actually is equal to the tangent of the angle, and the angle is actually over here. So there's a little bit of trigonometry.
Wait, let me get it straight. The tangent of the angle is equal to the gradient.
Yeah.
Seriously?
That will be something you'll be learning in the later
I
time.
know.
With the tangent theta over here, there's extra information. I'm just going to put it here, extra information. We can now proceed to calculate the rise of a run. So it's 28 minus 8 over 75 minus 50. Check all the units, seconds, meters per seconds. So it's fine, no need to convert. And then you have the answer after it in terms of meters per second. Done. And that's how we solve this question. You're lucky that this is a line. What happens if you want to find the acceleration here, for example?
Like the curve,
So what do you do?
applying the same thing.
But that only works for line. So what do you do? Ishva?
What are you finding?
The curve.
Why if you're finding the gradient of a curve?
You use.
What if you want to find
you use
over here? I want you to find me the gradient here. So what do you do?
You do math using circles.
So you see, you make
The pi r squared and 2 pi r.
yeah, so you look at quarter circle,
And it is a quarter circle actually.
yeah, then you do quarter, what, one quarter,
1 over
2
4.
pi r. Ah, that's how it is.
No, but the thing is we need to find the arm. We need to find the radius.
You have to draw a tangent to that point and then find gradient of that tangent because the tangent is a straight line.
I thought tangent equals gradient.
Tangent is a line. So gradient of a tangent is what you're supposed to be looking for.
Oh.